Yo, 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 yo. Gradius coming at you with the video about rational exponents, properties of exponents, solving equations with exponents, and all that fun stuff. So, welcome. Hope everybody's having a great day, and let's get at it. So, first thing we're going to talk about is what this is right here and how to evaluate an exponent that is a fraction. Okay, so first we know that if I were to do 3 to the second power, that is just the same thing as 3 times 3. I have 3 twice. Okay, and 3 times 3 is 9. That's how I would evaluate that. Well, 3 to the 1/2 power, how many times am I evaluating 3? We don't really know. Okay, so what we're going to do is we're going to learn a little formula that's going to help us determine what is 3 to the 1/2 power. Okay, now, here is my formula, and I really want to focus on this piece right here because this is how we're going to use it the most. Okay, still write out the whole thing, but this is really how we're going to rewrite them. So if we have a fraction, it's really just going to change into a square root. Okay, so it's just going to turn into a square root. So, and we look here, the numerator stays with the value. That's my new exponent under the radical, and then the denominator is which root I'm looking for. Okay, so let me show you what I mean by that. So this 3 to the 1/2 here, if I look at my formula, how my numerator stays as an exponent under the radical sign. So I'm going to have the square root. I keep my base under the radical. Okay, so my base was 3, so I'm taking the square root of 3. But this numerator is my new exponent underneath the radical. And then my denominator here is what root I'm looking for. And this, when we put a square on the outside, that's the square root. Okay, so really, the 3 to the power of 1/2 is just asking for the square root of 3. I don't need to write to the power of 1, and I don't need to write this 2 outside of the square, outside of the radical symbol, because the square root, it's already there. Okay, that's implied. Now, I know some people are asking, well, what if this was a 3? So it would be the same process, but so I still would put my base of 3, that stays the same, my numerator, and then now it's a cube root of 3. So my final answer would be cube root of 3. Let's say this was a 2. So now it was 3 to the power of 2/3. The only thing that would change is now this would be 3 squared. Okay? And so then it could be the cube root of 3 squared or the cube root of 9, and so on and so forth, because 3 squared is 9. Now, one thing I do want to look at is, let's take this and do a couple extra tries, and we're actually going to go backwards here. So go ahead and try this one on your own first, and then see if you can actually go backwards here and translate it from here to here instead of from the exponent to the radical. Let's see if we can go from the radical to the exponent version. So try it on your own real quick, and then check your answer. So 5 2/3, I know it's going to be the cube root because my denominator is 3, and it's a cube root of 5 squared. I can just leave it like that, and I'm done. Okay. Let's see here. I also have the 5th root of 7 to the 3rd power. Okay, so again, we're just going to go backwards now. I'm going to take this into exponent form. So I'm going to have a base of 7. My exponent here is my numerator, and my denominator is 5. So 7 to the 3/5 is the same thing as the 7 cubed, and the 5th root of that. Okay, that's it. So that's the first step. That's how we just evaluate and change our exponents with a fraction in it. We can change them to roots and vice versa. Now, here comes the fun stuff. Now we're going to use our properties of exponents in order to solve equations. So I have an equation here. 3 to the power of x over 2 times 3 to the power of x over 3 equals 3 to the 9th power. So my goal right here is to solve for x. I'm trying to figure out, well, what is x in this particular equation? This is where we're going to use our properties of exponents in order to solve the equation. So that's why we have to know our properties of exponents. We have to know the product of powers property. We have to know the power of powers. We have to know the quotient of powers. So let's take and let me rewrite this one, and let's see what we know here. I know that these are being multiplied by each other, okay? And so what I need to do is I have to know is if this is being multiplied, when I have a product of powers, what do I do with my exponents? So taking it back, if I had 3 to the let's make this a better number here. Let's go 3 to the 4th times 3 to the 8th. If I had 3 to the 4th times 3 to the 8th, we know we're just gonna, that's really just 3 to the 4th plus 8. We know we have 4 3s, 8 3s, so really it's 3 to the 12th power. We're gonna take that same property and use it here. So I have the same base here, I'm multiplying it. So really what I'm doing is I'm adding my exponents together. So I know that if I take 3 to the x over 2 and I add that with x over 3, that's going to give me how many I have. Well, I know really what I'm looking for is 9 because that's the right side of my equal sign here. Okay, so what we have here is I use my product of powers. I said I have a base of 3, same base here. I'm multiplying these two, so I really just add the 2 exponents. So I set that up where I added my 2 exponents together. Well, the right side is still 9. So if we look here, the only piece that really has to equal 9 is this piece right here. This needs to be equal to 9 for the left side to be equal to the right side. So now I can set up a separate equation over here. I can set it up underneath on the side. I just have more room over here. My equation that I'm really trying to solve is x over 2 plus x over 3 is equal to 9. Because if I have the base of 3, then I just need this piece to equal 9. And then they'll be equivalent. Now I have to actually solve my equation. Now some people are looking at this equation like, okay, well I have a denominator of 2, denominator of 3, and I'm adding, like I don't know what to do here because you have 2 fractions. Well, to add 2 values with fractions, you have to have a common denominator. So a common denominator would be 6. So I'm just going to multiply this whole thing by 3 over 3, multiply this whole thing by 2 over 2. So I have 3x over 6 plus 2x over 6 equals 9. Well, now I can add my numerators. 3x plus 2x is 5x. So I just have 5x over 6 equals 9. And now I get to just solve my equation. So the easiest way to solve this would be just to multiply by the reciprocal. So I can just multiply by 6/5 because these cancel and these cancel. Whatever I do on one side, I have to do on the other. Cannot cross simplify anywhere. 9 times 6 is 54. 1 times 5 is 5. So my final solution for x is 54 over 5. And I'm done. There's nothing else that I need to do. Okay, so if I were to plug in x, and I'm not going to, I can plug it in to check my work, and I'm just not going to do that right now for the sake of time. But if I were to plug in x equals 54 over 5 in for x here and here, and then I added and I solved this by using my product of powers, I would get 3 to the 9th power on the left-hand side. Okay? So let's look at another one. If you want to try this one on your own, try this one on your own. I've got another example for you. And if you don't, if you want to watch another one, watch another one. Okay, that's up to you. So again, I notice I have the same base. They're being multiplied. So I notice this is going to be a product of power situation where I'm really just adding my 2 exponents together, and they're going to have to be equal to 3. So this is really the same thing as 2 to the x over 4 plus x over 6, and that has to be equal to 2 to the 3rd power. So really, this piece right here needs to equal this one. Okay, so that's my separate equation. I know I have x over 4 plus x over 6 equals 3. Need to have a common denominator. My common denominator is 12, so I can multiply by 3 and multiply by 2. 3x over 12 plus 2x over 12 equals 3. 5x over 12 equals 3. And now I get to just multiply by the reciprocal, which is 12/5. All right. And now I'm looking at these, these simplify. Can I cross simplify at all? 3 and 5 don't simplify. So my final answer is 36 over 5. And I can leave like that. We don't have to change it to a mixed number. We don't change it to a decimal. Just leave it as 36 over 5. We are done. Oh, and I have a question for you. How do you stay warm in any room? How would you stay warm in any room? You would just huddle in the corner where it's always 90 degrees. Ha! Okay, moving on. It's a good one. This is your last one. Definitely try this one on your own, and then we'll see how you do. Okay, so try this one on your own, then you can check your answer. So again, I have product of powers. We have 4 to the x over 2 plus x over 5. I know I'm adding them because I'm multiplying two numbers with the same base, and that's equal to 4 to the 8th, which means this x over 2 plus x over 5 has to equal 8. So there's my equation really that I have to solve. I'm going to multiply by 5 over, I guess it's technically 5 over 5, and I'm going to multiply by 2 over 2, because there it's going to give me my common denominator of 10. So 5x over 10 plus 2x over 10 still equal to 8. Now remember, I'm not multiplying both sides by 5 and 2 because this is just to find a common denominator. I'm really multiplying this by 1. I'm multiplying by 5 over 5, so I'm not changing any values. I just want to make sure that's clear. That's why we're not multiplying the 8 by anything as well. You know, a lot of people think on the equations you have to keep the two sides balanced. Well, we still are, because 2 over 2 is 1, 5 over 5 is 1. Whenever you multiply something by 1, you're not changing it. I can add these up now. So I get 7x over 10 equals 8. Now I get to multiply by the reciprocal, which is 10/7. Cannot cross simplify at all. So I get a final answer of 80 over 7. All right. So that's all I got for you. Let me know if you have any questions. Shoot me an email and do your best. Tomorrow we'll do part 2 of this. This is only just part 1, where we're going to use different properties. I wanted just to start off nice and simple with product of powers. We'll do power of a power, quotient of powers tomorrow, and just take it to the next step. Okay, hope this video helped, and good luck. Thanks for watching. Gradius out.